We're going to do another Math 2B midterm 1 that was given in fall 2017. So I have not solved these problems before. I'm going in blind like an exam. I do have to key this, so I'll be checking my answers against that. Okay, so let's begin. Excuse me. Number 1, it says use definition of the definite integral to evaluate integral from 0 to 2 x cubed dx. And then the professor in this exam just gives us these formulas to help us out, okay? Excuse me. So we're going to use those in a bit. Remember what the Riemann sum is? Remember the integral from a to b, f of x dx. This is defined as the limit n goes to infinity, summation as I goes to 1 to n of f of xi delta x. And recall that delta x is b minus a over n, and x of I is a plus delta x times I. Remember, delta x is the width of the rectangle, and x of I is the sample point. We start from the leftmost point A, and we increment by widths of our rectangles. That's how I remember it, okay? So, what's delta x in our case? B minus a, that's 2 minus 0, that's 2 over n. And then our x sub I, our a is 0, so it's just delta x times I. So that is 2i over n. So our integral is, so we call this I. Then I is equal to the limit n goes to infinity of summation I goes to 1 to n of f of x sub I. Our f of x is x cubed, so we have 2i over n cubed times delta x, that will be 2 over n. Okay. So we can rewrite this as limit n goes to infinity. This 2 over n does not depend on I. We can move it out of the summation. We can't move it out in front of the limit yet. Well, we can't do it, period. Okay. This is... we can break this guy up into 2 over n cubed and I cubed multiplied together. So actually, this would be to the 4th power summation I goes to from 1 to n of I cubed. Okay? So I went from here to here is this guy we can move out of the summation sign. It's just a constant, does not depend on I. This guy we can break it up as 2 over n to the 3rd power times I to the 3rd power. Again, 2 over n to the 3rd power, that guy does not depend on I, so we can move it out. So we have a 2 over n to the 4th power. We have I cubed still, okay? Here we use our lookup charts, formula table, whatever. That's n squared, n plus 1 squared over 4. So we write this as limit n goes to infinity of 2 over n to the 4th. The summation is this, so we plug in. Okay. Now how do we find this limit? Well, let's move some constants out first. This is 16, 2 to the 4th power is 16. Divide by 4, that's another 4. That's 4 in front. Limit n goes to infinity of, we would have some n to the 4th on the bottom, because from here, n to the 4th. And then over here we have n squared plus 2n plus 1. I just expanded this guy. Okay? The limit as n goes to infinity of this, remember we can, in math 2a, this is a horizontal asymptote. So we can check the degrees of the top and the bottom. The degree of the biggest term on top would be n to the fourth. Degree of the bottom would also be 4. Excuse me. So because the degrees are the same, we can take the ratio of the leading coefficients. They'll just be 1. So 4 times 1, which is equal to 4. Okay, let me check that that's the answer. Yes. And of course, you can always check your answer by actually doing the integral with the power rule. Okay, does it ask us to do that actually? It does not. But since we have time, let's check mentally actually. It'll be x to the fourth over 4 when we take the antiderivative. Evaluate from 0 to 2, so what matters is 2 to the fourth divided by 2. 2 to the fourth is 16. Divided by 2, that is 8. So did we get this right? Did I get it wrong? Did I do the antiderivative wrong? Oh, sorry. It'll be x to the fourth divided by 4. Yeah, I did the antiderivative wrong because I was doing it in my head. So, my bad. When we take the antiderivative, b to the power x to the 4 divided by 4. Evaluate that from 0 to 2. So what matters is x to the 4th 2 to the 4th divided by 4, which is 16 divided by 4, 4. Matches. Okay. Let's move on to number 2. So 2a, it says position s of t of a particle with acceleration a of t is equal to 2t plus 1, and s of 0 is 3, and v of 0 is minus 2. Oh, let's find the position s of t of a particle with acceleration a of t is this guy, and they give us initial conditions. S of 0 is 3, v of 0 is minus 2. Okay? So how to do this? We have to integrate. Integral of a of t dt, that's v of t, velocity, is the integral of acceleration. Remember, acceleration is the derivative of velocity, so velocity is the antiderivative of acceleration. So, it's the integral of 2t plus 1 dt. That's just t squared plus t plus c. Okay? We are given v of 0 is minus 2. So we plug in 0 to here, we get 0 plus c. So c is minus 2. So v of t is actually t squared plus t minus 2. And now we can find s of t, that's the antiderivative of velocity, or integral. Okay, so that's just the integral from t squared plus t minus 2 dt. Again, we just use power rule, that's 1/3 t cubed plus half t squared minus 2t plus c. We are given that s of 0 is 3. So that is 0 plus 0 minus 0 plus c. So c is equal to 3. So s of t is equal to 1/3 t cubed plus half t squared minus 2t plus 3. Let me check that's the answer. Yep, that's correct. Okay. So in this one, you just have to know position is you have to integrate twice. So yeah, the antiderivative of acceleration is velocity. Antiderivative of acceleration is velocity. Antiderivative of velocity is position. And then we're given initial conditions to find our plus c's. Okay. Not bad at all. Let's move on. To b, we're asked to evaluate minus 1 to 1, x plus 1, square root 1 minus x squared, dx. Okay, how can we solve this? the clue here should be, it's from -1 to 1. Maybe we have to use the property of even and odd functions. Can we do something like that? Because it's not a substitution per se. I don't see an obvious substitution, because if u is 1 minus x squared, du is minus 2x dx, but then we don't have something that looks like that here, so it's probably not that. Maybe what we can do is we can distribute the square root to both terms. So it'll be x square root 1 minus x squared dx plus integral from -1 to 1 square root 1 minus x squared dx. I just distributed to both terms, so we have this integral and this integral. We can break up the integral of a sum of multiple things. Okay? So this one, we see that if this is f of x, we see that when we plug in f of x as minus x, we get minus f of x. So if this x square root of 1 minus x squared, we plug in f of minus x, we get minus f of x, which means it's an odd function, because when we plug in minus x, this would be the same, but then this x would become minus x. This is an odd function, so this guy would be 0. Okay? Plus, how about this guy? This guy, we don't know the technique per se, but we do know that this is an equation of a circle. Particularly, it's this up here, this bold part. So let me emphasize it. Sorry, that's a bad picture. Maybe I should just do it like this. Okay? This is the equation of this. This is a semicircle, which we know the area of. That's just pi over 2. Okay? Pi r squared is the area of the full circle. R is 1. So it'll be pi, but then half of the circle, so pi over 2. So it'll be it'll be 0 plus pi over 2, so it's pi over 2. That's how we solve this one. The technique here was we distribute, we get these two integrals. This one is an odd function, so since we're integrating from -1 to 1, the area of the negative would be negative the area of the positive. So then it would be 0. This one, we had to realize that, well, we have to know, first of all, that integral is area under the curve. This guy is just a semicircle, so we know how to find the area of the circle, which is pi r squared, where r is the radius. The radius in this case is 1, and it's half of a circle, so it's pi over 2. That's how we solve that. Okay? 2c, it says find the derivative with respect to x of integral from e to the x to x of sine t squared dt. This is a good old fundamental theorem of calculus. Very easy. Okay? How to do this? Like I said this in previous videos. So let's say this is equal to f of x. So f prime of x, we say, how to do that? We plug in the upper bound times derivative of the upper bound, so d by dx of x, okay, minus, plug in the lower bound, e to the x quantity squared is e to 2x, and then times derivative of the lower bound. Okay, that's the way we do it. We simplify, d by dx is just 1, so we have sine of x squared minus derivative of e to x is e to x, sine e to 2x. That's our answer. As simple as that. Fundamental theorem of calculus, very easy. Okay. Let's move on to the next page. (3a) Find average value of the function cosine to the fourth sine x. on the interval from 0 to pi. Okay? How do we do average value? This is very easy. It's 1 over b minus a, integral from a to b, f of x dx. That's literally the average. Just summing up all the terms of f, divide by the range of f, okay? So that is 1 over pi minus 0, that's 1 over pi, integral from 0 to pi of cosine to the 4th sine dx. Okay? How do we solve this? We let u be cosine x, du is minus sine x, dx. So let's change the limits of integration now. If x is 0, u would be cosine of 0, which is 1. And if x is pi, then u is cosine of pi, which is minus 1. Hopefully you can see that minus sign. Okay? So this becomes 1 over pi integral. It'll be from 1 to minus 1. Okay, let me just write 1 to minus 1 of u to the 4th times minus du. Okay? We could just evaluate it as is, but to make it look nicer, we can switch these limits and multiply by minus 1, correct? We have another minus sign here, so when we flip it, there's a minus from that. We still have this minus sign. It'll be positive. So u to the 4th du. We could solve from here, but actually we realize that this is an even function, so we can even say it's 2 over pi integral from 0 to 1 u to the 4th du. It's even function, so we can do that. This is 2 over pi times u to the 5th over 5. Evaluate from 0 to 1. Okay? This is just 2 over 5 pi. Let me check that's the answer. Yes. Okay, so that's how we solve that. Just have to remember what average value is. And then the integral was quite easy to solve. Okay. 3b, we've asked to find area of the region enclosed by y is cosine x, y is minus cosine x, x is 0, x is pi by these 4 curves. Okay, so the go-to is you should sketch this region. Okay, so this is 0. Let's say up to this point is pi over here. Okay, so cosine x, how does that look? Let's define this point pi over 2. So this is 1 and minus 1, okay? Plus 1, minus 1. Cosine starts at 1, correct? And then it would go like this. Okay? This is, let's call this y1, y2. This is y1, okay? Minus cosine x is just flipped over the x-axis. So it would look something like this. This is y2, let's call it, okay? We want to find the area of the region enclosed by this curve, and 0 and pi. So pi is here, so let's draw a vertical line there. How to do this? So we had to find this region and this region. Remember, area between curves is upper curve minus lower curve. The tricky part here is upper curve is y1 up to pi over 2. Lower curve is y2 up to pi over 2. And then they switch. After pi over 2, upper curve becomes y2. Lower curve becomes y1. That's the trick here. So area, we have to set up 2 integrals. Integral from 0 to pi over 2. Upper curve is, we said was y1. That's cosine x, minus lower curve, that's minus cosine x, dx, plus integral from pi over 2 to pi. The upper curve here is y2, that is minus cosine x, and then minus the lower curve, which is y1 is just cosine dx. Okay. So this is just 2 integral from 0 to pi over 2 cosine x dx plus, this would be actually a minus 2 integral from pi over 2 to pi of cosine x dx. Okay? We evaluate this. This is just 2 sine x, evaluate from 0 to pi over 2, minus 2 sine x, evaluate from pi over 2 to pi. Okay? This is just 2 times 1 minus 0, minus 2 times sine of pi is again 0, minus sine of pi over 2 is 1. So we get that, which is 2 plus 2, which is equal to 4. Okay, that's how we solve this one. Again, the trick is the upper curve and the lower curve change, so you have to write two integrals. And if you were smart about it, you would know also that they're symmetric, so you get just 2 times the first integral or something like that. But I showed you the long way to do it, which also works. Okay? And then we have one more problem. Oh, this is a very fast midterm. It's a volume problem. So we're asked to find the volume of the solid obtained by rotating the region enclosed by y is e to the x, y is 0, x is 0, and x is 1 by rotating the region enclosed by this about the line y is equal to minus 1. Okay, so as always, let's sketch our region. E to the x, how does that look like? That looks like this. Okay. Y is equal to 0, that is the x-axis. X is equal to 0, that's the y-axis. X is equal to 1, let's say this is 1, that will be up to here. So we're interested in this region right here. Okay. We're rotating this about what line? About the line y is equal to minus 1. So that means if we draw a dotted line here, this is y is equal to minus 1. This is our axis of rotation. Okay? So if it helps, you can draw a cross section. It will look something like this. Okay? Or even if you want to flip it, it'll look like that over there. Okay? But I'm not going to draw that. Okay? Because I'll just show you what is kind of needed. What I feel like is needed. If it helps you to visualize, go for it. Okay? Remember, volume is pi integral from your region of interest r out squared minus r in squared. Okay? In this particular case, we only have an r out, but this is the general formula. And then it's by dx or dy. In this case, we would do dx, let's say. When we're rotating about a horizontal axis is dx, vertical axis is dy, if we're doing the washer or disk method. Okay? That's the method that you learn in math 2B. So, horizontal axis is dx, vertical is dy. Okay? So, what I always do is, I sketch the region and the axis of rotation. I draw a representative r out and r in. In this case, there's only an r out, so let's just draw a radius r out, like this. Okay? Technically, our r in, actually we do have an r in. It's this, r in. my bad. There's an R out, there's an R in. I'm solving this live, as always, okay? So now we need to get the length of R out and R in. Okay? So, how to do that? Well, we know that this length from the x-axis to here is length of e to the x, the exponential. This length here. Okay? So we just add on this additional length, which we know is a length of 1, because this is the axis, this is y is minus 1. This is additional length of 1. So the r out would be 1 plus e to the x squared. R out squared is that, okay? Minus r in is this length. What's this length? It's just a length of 1. Okay? As simple as that. So we solve this. This is volume. V is equal to pi integral. Let's expand this. That'll be 1 plus 2e to x plus e to 2x minus 1 by dx. This one and this one would cancel. So now we integrate here. That would be pi times 2e to the x plus half e to 2x. You could do a substitution there if you want. I just did it in my head. Plus, if you differentiate this, you get e to 2x. Okay? Oh, we forgot our limits of integration. What are our limits of integration? What's our region between in terms of x? X is from 0 to 1. Okay? 0 to 1. 0 to 1. So evaluate this from 0 to 1. Okay? So we use fundamental theorem of calculus. That'll be pi times 2e plus half e squared minus 2 plus half. Okay, so then this is just pi times 2e plus e squared over 2. This is, what's this, minus what? Minus 5 halves. Yep, that's the answer. That matches the key. Okay, good. So here, the technique that I go by is always sketch the region, and I sketch the axis of rotation. I draw a representative R out, I draw a representative R in. In this case, R out is like that, R in is like this. Okay? R out, what's the length of R out? Is the length, this length plus an additional 1. What's this length up here? That's just e to x. What's this length here? That's just 1. So 1 plus e to x and 1. Okay? And then we solve the integral. Okay? So this is a pretty simple midterm. Hopefully it was not difficult for you. The tricky part was this one they flipped, so you have to be careful there. And then this one, the technique was one's an odd function, one's the area of a half circle. So those are the tricky parts. Others was not too bad at all. There was actually not much evaluation of indefinite integrals using like substitution and all that, so that's not bad for this midterm. Okay, yeah, so if this video helps in a way, please hit that like button and please subscribe to the channel for more videos like this.